5-3 then takes 5-1 and 5-2 and goes backwards with it. Okay, so we learned if we have a normal curve and either a raw score or a z-score, right? Most of the time a raw score. Our process is that we take our raw score, we convert it into a z-score, and then find probability. That's kind of our order, right? We're first given a raw score, we convert to z-score, and depending if it's less than, greater than, in between, we can then find the probability. So what 5-3 does is sometimes you know the probability. So how then do you go backwards to a z-score and then finally back to the raw score, your answer, to get what that probability means, okay? Why do we need to go backwards? A lot of times companies offer warranties. Your watch will last 2 years, guaranteed. Your new air conditioner, right? Guaranteed 36 months. How do they get those guarantees? Well, companies know that they only want to replace probably 10% of their product, okay? We'll replace 10% of our product. So as a statistician, if the CEO is telling me if she wants to make a 10% guarantee, what does that guarantee need to be? How many years? How many months? Okay, so that's the biggest example I can tell you of why you would go backwards. Sometimes you know the probability, but you want to know what raw score gives you that probability. Okay, so to do that, you need to take the formula I gave you the other day and solve for x. And when you solve for x, you get this formula, okay? So if I start with the probability and I find what z-score is that probability by using the table, right, in the back of my book. So to go from probability to z-score, I use the table. And then to go from z-score to raw score, I have to use this formula. I take the mean plus z times the standard deviation. Okay, so again, I still need mean and standard deviation in order to compute this, but now I'm going backwards, okay? So what you're looking up is, on your appendix, you're looking up all of the probability numbers, right? Everything in the table. And that'll give you, right, the column, the row and column z-score, which then you can use this formula to convert to a raw score, an answer. Okay, so let's try some examples here. Okay, so this is what's given to you. It's given that the probability is 0.9251, right? This is 0.9251. I want to know what z-score represents that probability. Okay, so you're still using that same table on A16, okay? But now your answer is going to be in these numbers here, right? You're not looking up a z-score, you're trying to find the z-score. So you're looking at these numbers. So if you notice, the smallest probability is in the top right-hand corner, and then it gets bigger and bigger and bigger to 50%, and then it starts 50% and gets bigger and bigger and bigger all the way to almost 100% down in that corner. Okay, so if I want to know 0.9251, I'm over here. 0.9251 is right there. You see it? 0.9251. The z-score that represents 0.9251 would be 1.44. See that? If I look up the z-score, 1.44, that is the probability 0.9251. So my answer for this would be 1.44. Okay. Now the big thing to remember is that this table only does area to the left. Okay. So if you are given a probability of to the right, right, 0.005, I can look up 0.005 and do the opposite, because that's what we know about area to the right, or I can just do 1 minus that and get 0.995. Sometimes that's a little bit easier and not as confusing. Okay, so again, 0.995. I want the z-score for 0.995. So I'm going to be over here on the right side again. 0.99s are way down here. So 0.995, right, you should notice they go in order. 0.995 isn't on there. I have 0.9949, 0.9951, but I don't have 0.995. When a probability lands smack dab in the middle of two z-scores, right? One's not closer than the other, it's right in between. I split the z-score. So I would take, what is that, 2.57 and 2.58, and what number is between that? So 2.575. Okay, because 2.57 gave me 0.9949, and 2.58 gives me 0.9951. I want 0.995, so I have to split those two z-scores, and that gives me 2.575, right? The number in between those two z-scores. So if it lands smack dab in the middle, you split it, okay? Let's try another one. Okay. So here, area to the left, the probability is 0.05, okay? So 0.05, that's gonna be on the left side here, 0.05. So again, see how I have 0.0495? That's 5/10,000ths away. And then I have 0.0505, that's also 5/10,000ths away. So again, I'm going to split that z-score. So negative 1.645. Right? Because negative 1.64 was 0.0505. That's too big. And negative 1.65 was 0.0495, too small. And since 0.05 is exactly in the middle, I split that z-score perfectly, right? Divide by 2. Okay. So what happens if it's not there but it's closer to a number? So let's do 0.9862, right? So if you look up the probability 0.9862, it's going to be on the right side, 0.986. Okay, so see here I have 9.61, and the next one is 9.9864. Well, 0.9862 is closest to this z-score. It's not in the middle, right? That would be 0.98635. It's actually closest to this z-score. So if it's not exactly in the middle and it's closest to a z-score, you're going to use that z-score. So I would use 2.20. Okay. So that's what you're doing. You're going backwards. So you have lots and lots of probability numbers to look at, right? To find what z-score is for that. Okay, so a couple other things that can happen is how do you do then area in between? Okay, so if in doubt, sketch it out. Remember, I always say that. I want the middle 90%. So area in between, I have some negative z-score and some positive z-score. Here's my mean. And I want this to be 90%. Okay, so if it's the middle 90%, what do I know about each one of these halves? It's 45%. Yep, because I know 45 plus 45 equals 90. Okay, now, if I know the mean here is 50-50, then I'll know these percents, right? Because I know this half is 50. So this must be 5%, and this must be 5%, because 45 plus 5 is 50%. That gives me 50, that gives me 50, gives me 100. Okay, now, I need to know this z-score and this z-score. I can look both of those up now, because in order to find this z-score, I can look up 5%, okay? So 5% as a decimal is 0.05. So pulling out my book, 0.05%, right? So you're not looking up a z-score, you're looking up percent. And you should notice 0.05 again lands right between two z-scores. And we kind of already had this earlier. So negative 1.645. Okay. Now, you can know that these are just complements of each other. Because if this is 5% and this is 5%, I should know this is a positive. If you don't know that, the other way you could have done it is 90 plus 5 is 95%. So if I look up 95% over here on the right side, it lands right in between two numbers, and it's 1.645. Okay? So when you do area in between of a middle percent, there'll always be opposite numbers of each other that will happen. But you can always add up all the area to the left and look it up that way too, looking up by its probability. Okay. Let's do one more here. Find the z-value such that 3% of the area under the standard number is to the right of that z-score. Okay. So like I say, if in doubt, sketch it out. I want 3% to the right of the z-score. Now, I can look up 3% and do the opposite number, or what's a little bit easier is I can look up 0.97 because now I have 100%. Okay, so what z-score is for 0.97? So 0.97, you're over here. So it's 0.97 is closest, it's not in here, but it's closest to 1.88. Okay, so before we throw in some applications to this, I do want you to pause here, pause this video, and go to your book on page 257 and do 17 through 28. Okay, so you're just practicing finding the z-score first. Okay, and what else am I going to do is I'm going to hold up the answers here in just a second. So I would pause this video, try the homework, and then push play again so you can see the answers. Okay, so try 17 through 28, and here are the answers. Okay, I think you can see those, right? So here's the key for all 17 through 28, okay? So you should be done with the homework now and be able to be checking these answers, okay? If you're not sure, ask me, right? But you really need to understand this now in order to do some application problems. Okay, so let's move on to some applications. hold on. Okay, so here's an example of where we would use this, right? Percent back to raw, okay? And again, that formula you need now that you're doing application problems, the formula you need now is for the raw score. Okay. The management of a supermarket wants to adopt a new promotional policy of giving a free gift to every customer who spends more than a certain amount per visit at the supermarket. The expectation of the management is that after this policy is advertised, the expenditures for all customers at the supermarket will be normally distributed, you need that, with a mean of $95 and a standard deviation of 20. Okay, so we need those mean standard deviation. If the management wants to give free gifts to at most 10% of the customers, what should the amount be above which a customer would receive a free gift? Okay, so these problems are really going to be handy if you kind of sketch it out, right? So let's sketch out a normal curve. I know my mean is $95 and my standard deviation is 20. Now, if I only want to give the top 10% of my customers free gifts, right? How much do they have to come in and spend? So I'm looking at a 10% that's up here. So I want to know, what does that z-score, what is a z-score that equals 10% that I can convert to a raw score? So in my book, I'm looking for 10%. So what is that as a decimal? 0.1. So I'm looking at 0.1. And it's not in here exactly, but it's pretty darn close to negative 1.28, right? Negative 1.28. Now, negative 1.28 gives me the bottom 10%. So I know this z-score must be a positive 1.28, okay? If you don't like that way, the other way you should have done is, if I know this is 10%, what's this? This is 90%, right? So I could also have looked up 0.9, and right here is the closest. And that again is 1.28 is the closest. Okay, so either way, you can do it by the opposite, or if you know this is 10, this has to be 90. Okay, now 1.28, that doesn't tell me anything. A customer needs to be 1.28. What? I need money, right? I need a raw score. So using this formula up here, I take the z-score, which is 1.28, times the standard deviation and add the mean to it. Okay, so this answer, 1.28 times 20 plus 95 is $120.60. Does that make sense? The top 10% of my customers will spend more than $120.60. That makes sense, right? If the mean is 95, I know 50% spend more than $95, so 10% must spend 120 or more. That's the answer I'm looking for. So if I was going to make an advertisement, right, I would say you have to spend more than $120 and then you get a free gift, right? Then I know as a manager, as a store CEO, that I'm only giving out 10% of my gifts, and I can have an idea of what my cost is going to be on that promotion. Okay, let's try another one. Suppose that the time to complete a test is normally distributed with a mean of 40 minutes and a standard deviation of 5. After how many minutes can we expect all but 3% of the tests to be completed? So I want everybody to be done except for 3% of the people. So is that going to be more than the average time or less than the average time? More than the average time, right? So this is I want the top 3%. How much time does it take for almost everybody to finish except these 3%? Okay, so what I need is a z-score. So what's the complement to 3%? 97. So I want to look up 0.97 in my probabilities. So that's way over here, 0.97. And it's closest to 1.88, right? That's going to be the closest. I don't have 0.97 exactly. So I would say 1.88 as a z-score. Okay. Now, that doesn't tell me anything, right? 1.88 what? I need minutes. So let's convert this back to minutes. So I take my z-score times my times my standard deviation, times my standard deviation, add the mean, and I know that 1.88 49.4 minutes, right? Okay, so within a 50-minute class period, I can expect almost everybody except for that 3% of my students to maybe have to stay later and finish the test. Okay, most will be done though. 97% of my students will be done within the 50 minutes, right? 49.4 minutes. Maybe let's do one more here. Acrotime is a manufacturer of quartz crystal watches. Acrotime researchers have shown that watches have an average life of 28 months. Before certain electronic components deteriorate, causing the watch to become unreliable. The standard deviation of watch lifetime is 5 months, and the distribution of lifetimes is normal. Okay, if Acrotime guarantees a full refund on any defective watch for 2 years after the purchase, what percent of total production will the company expect to replace? Okay, so if you buy a watch and it's guaranteed to last 2 years, when will you get a free watch? If it lasts less than 2 years or more than 2 years? Less than 2 years. If you have a watch and it lasts less than 2 years, you're going to get a free one. Okay, so I want to know what percent. So 2 years we know is 24 months. I want to know what percent of watches last less than 24 months. This is 5-2. I want to go from a raw score to a probability. So I'm going to do 24 minus the mean, divide by standard deviation. Right? That'll give me a z-score. And since I'm doing less than, I can just look up that z-score. Okay, so now don't get confused. You're looking up a z-score. Now that is the darker black numbers, negative 0.80. I get a percent of 0.2119. Okay, so if I make a guarantee for 2 years, I know that I'm going to be replacing over 20% of these watches. Okay, so the CEO, she doesn't like that. She says that's a lot of watches that we're replacing. Okay, that's too generous of a warranty. So as a statistician, you ask the CEO of Ford or Chevy, right? Those are warranties. Of Kia, why is Kia's warranty on a car longer than Ford? What do you want to replace as a company? What do you want to say that will be cost effective? And the CEO says, okay, I don't want to replace any more than 12%. So now what does this warranty need to be so I'm not replacing more than 12% of my watches? Okay, so now this is 5-3, you're going backwards. I have a percent that needs to go back to a z-score to then find the raw score, how many months. So 12%, okay, so I'm replacing the bottom 12%. So what is that z-score for 12%? So now I'm looking at the lighter black numbers, 0.12. And this one's going to be splitting. So negative 1.175. Okay, that's my z-score. So now I need the other formula times the standard deviation, add the mean. What does my guarantee need to be? So negative 1.175 times 5 plus 28, 22.125. Okay, so your job as a statistician is to deliver this information. Now the board, the CEO, will decide, should we say 22 months or 23 months? If we say 22 months, it's going to be little over 12%. If we say 23 months, then we know it's going to be a little less. Okay, so that's kind of the decision. Your job is to give them the numbers, and it's their job to then to say, what do we want to do? Okay. All right. So then after you did that first part, remember 17 through 28, you're going to finish up this homework with 5-3 on page 2, so it's page 258. And you're going to do 35 through 40. Okay, so 35 through 40 is then applications of going backwards. Okay, so percent to z to raw. Okay, and remember the odds are in the back of the book. Look those up. And then we're gonna pause here, have an activity, take a quiz, and then we'll finish up chapter 5 after that.